All right, guys, so before we get started, are there any questions on the homework assignments? So the first thing we're going to look at today is addition, subtraction of matrices, adding and subtracting two matrices. Now, whenever we add or subtract two matrices, the sum or difference of two matrices with different dimensions is undefined. So the dimensions have to be the exact same. If the dimensions are the exact same, we add or subtract their corresponding elements, depending on what the operation tells us. So, let's take a seat. Guys. So if we have two matrices that are being added together, here we have a 2 by 2 and a 2 by 2. We will add the corresponding matrices, the elements. So A is in the top right. Try this again. A is in the top right. E is in the top right. So we'll add those two together. Now B is in the top left. F is in the top left. So we'll add those two together. The ones that correspond we'll add together because we're adding. C and G are in the same spot, so we'll add those together. And lastly, D and H are in the same spot, so we would add those together because it said we're adding the two matrices. The same thing is it goes the exact same way with subtraction. You would subtract the corresponding elements instead of adding. So let's look at the first problem here. So when we look at both of these here, the first matrix is a 2 by 2. And we're adding to it a 2 by 2. Since the dimensions are the exact same, we can add. Bless you. Yes, sir. Thank you. Now, we would say 2 plus 1, because those are in the same spots. Then we would say negative 1 plus, because those are in the same spots. Yes. Then we could say, we're seeing, yep, 3 plus 4, and lastly 0 plus negative 2. Because we're just adding the elements that are in the same spots. Hey, what does your shirt say? We can talk about that later. Because we're focused on this here. Now, we can go on and simplify. So we can say 2 plus 1 is, negative 1 plus 2 is 1. 3 plus 4 is, and 0 plus negative 2 is. And that's it. Okay. Let's look at the next one here. Are these two matrices, do they have the same dimensions? So that means we can subtract them. And we want to subtract the corresponding elements. So we would say 2 minus negative 1. Because 2 minus negative 1. Then we would have, yeah, so negative 3 minus 2. Well, the next one would be 2 minus 7.
Roy, you're all messed up. Wait, what? Oh, yeah, my bad.
4 minus 8. I think you were going straight down.
Yeah,
Negative 2 minus negative 5. And lastly, 8 minus 6. We're matching up the like elements or the corresponding elements and subtracting them. So 2 minus negative 1, 3 minus 2, 5 minus 7, 4 minus 8, 2 minus negative 5, and 8 minus 6. And then we subtract. Well, 2 minus negative 1 is the same as 2 plus 1, which is 3. 3 minus 2 is negative 5. 5 minus 7 is negative 2. 4 minus 8 Negative 4. 2 minus negative 5 is 3, because our negative negative makes plus. And lastly, 8 minus 6 is, and that's it. Each element per the matrix, each part of the matrix E.
Is that what this whole paper should be over?
These addition, subtraction, and scalars. Any questions on any of this here? Are these two matrices, do they have the same dimensions? So can we add them together? No, this one here is undefined. Because if the dimensions aren't the exact same, we can't add or subtract. We just say it's undefined. Any other questions on this here? Yes. For putting stuff up on. But guys, let's focus in here. Guys, we're going to focus in here. So, looking at this next one, can we add these two together? Yeah, because we have a 2 by 2 and a 2 by 2. Now, if we wanted to, we can actually use the calculator to do this. Because what we can do is define the first one as matrix A, and define the second one as matrix B, and then add those two together. So if we pull up the graphing calculator, the first thing we can do is say second matrix, and go over to edit, and press enter. Now the first matrix is a what by what? A 2 by 2. So we can define it as a 2 by 2. And then we'll put the numbers in. And our first one is negative 1, 7, 5, and 3. So we want to put our numbers in for the first matrix. Questions on this so far? We're good? Now we can go second quit, second matrix, and this time we want to define matrix B, which is a 2 by 2. And this time we have 6, negative 4, negative 8, and 2. Because we want to put the numbers in for matrix A and then put the numbers in for matrix B. Any questions on this so far? Now what we can do next is a second quit. Now we just need to recall the matrices. So the first one we need to call up is matrix A. So we can say second matrix, and then we can hit enter for A. Which part? Second matrix, enter. Like when we recalled them yesterday or Friday for doing solving, we're doing the same thing. We're just calling them back up. Now what are we doing to it? We're adding to it matrix B. So we can say plus. To call up matrix B, we would say second matrix. And this time, instead of just hitting enter, we'll scroll down one to select B, then hit enter. So we have A plus B. And we get 5, 3, negative 3, 5. Guys. And that's it. Questions on this here? Now, if we look back at this here for the problem, well, we're saying that we have negative 1 plus 6, 7 plus negative 4, 5 plus negative 8, and 3 plus 2. Well, negative 1 plus 6 is 5, 7 plus negative 4 is 3, 5 plus negative 8 is negative 3, and 3 plus 2 is 5, which is the same thing it gave us. Any other questions on this here? Now, For the most part, some of these here with addition and subtraction, it might just be just as fast to go on and add them together than it is to try to type it in. Any other questions on this here? Is it possible to subtract these two here?
Yes.
Because the first one is a 2 by 1, the other one is a 2 by
1.
so we can subtract them. So we could do this in the calculator or we could do it by hand. Either one will work.
1.
Because we'd have 2 minus negative 3. Plus gives us any other questions on these here?
I have one serious question for you.
Okay.
What is your favorite number?
Not one that I can think of off the top of my head.
I have a serious question.
Okay.
What's that purple light? I'm not interested. Is it like not a light? Yeah, what is that?
A fly trap.
A fly trap? Bro, you ain't seen the commercial?
Guys, focus back up here. If there's other questions on addition, subtraction, we're going to look at the other part of the lesson, which is scalar multiplication. Guys, Logan, focus up here. Scalar multiplication, we're just multiplying everything in the matrix by that number. Let's stay eyes up here. Now we're going to multiply everything in that matrix by whatever that number is. So let's look at the first one. So here our scalar is 2. So we want to multiply everything in that matrix by 2. So we'll have 2 times 3, which is 6. Then we'd have 2 times negative 2. Huh?
You have to go rewrite it all, or just...
You can go on and just do that. I'm rewriting it so that we can see how it's looking, how we're doing this, because it'd be 2 times 1, 2 times 5, 2 times 2, and 2 times 0. Because we're multiplying every element in that matrix by 2. Guys. So 2 times 3 is 6. 2 times negative 2 is negative. 2 times 1 is 2 times 5 is 2 times 2 is, and 2 times 0 is.
I didn't know that.
Yep. And again, we could do this. Brendan, turn around. We could have done this in the calculator by defining this matrix A and saying 2 times A, or 2 and then pulling up matrix A and hitting enter. It would do the same thing. We could also do this here. We can combine the two. We can apply scalars and add and subtract. When we do these by hand, the first thing we'll want to do is to apply the scalars to each matrix and then add or subtract the corresponding matrices. So the first thing we can do is multiply this first one by negative 3. So we'd say negative 3 times 5, negative 3 times 0. Then we'd have negative 3 times negative 2, and negative 3 times 4. Well, we can go on and simplify the first matrix. Well, negative 3 times 5 is negative 15. Negative 3 times 0 is 0. Negative 3 times negative 2 is positive 6. And negative 3 times 4 is 12. 12. 12 And then we have this here. Now, we do need to add them together. So we'd say negative 15 plus negative 1, 0 plus 7, 6 plus 3, and negative 12 plus 2. Well, negative 15 plus negative 1 is negative 16. 0 plus 7 is 7. 6 plus 3 is 9. And negative 12 plus 2 is? That's your answer. Now, once we start getting into more of these scalars, doing scalars with addition, that's where typing it into the calculator can actually be a little bit faster, especially when we're trying to think of with negatives and subtracting negatives or multiplying with a negative scalar. This works a little bit faster, and we don't have to try to make sure, am I applying the negatives correctly? Am I making sure the signs are right? Questions on this here? Yes. Yes. Yep. You can apply it to both. I'll give this back to you when you get back.
Oh, thanks, Steve.
So we could have a negative scalar on both. So we can use these two here. So if we pull this up, we can say second matrix and go over and edit matrix A. And it's still a 2 by 2, so we'd say 5, 0, negative 2, 4. Then we say second, quit, second matrix, and we can go over edit matrix B. Still a 2 by 2. We have negative 1, 7, yeah, 3. So are there any questions on how we enter these in? Because I think at this point we feel comfortable inputting the matrices. Now, when we look at these here, I would type them in exactly as we see them. So we have negative 3, second matrix A, in front of matrix A. And we can just put it there. We don't have to hit the multiply. It understands that that's going to be multiplied. So negative 3, and then we can say second matrix A. So it understands multiplication. We don't have to hit the times button to say that they're being multiplied. Then we could say minus 6, and then call up matrix B, and hit enter. And it'll calculate it if we had minus 6, because the problem itself doesn't have that. Because we can do this in any way we want, because we could say alpha y equals enter, because alpha y equals enter will give us a fraction. And I could say 2/5 second matrix A plus alpha y equals enter 7/3 second matrix B. We'll do that there. So really, especially when we get to longer ones where we have 2 or 3 matrices, we can just plug them all in exactly as it appears and define it that way. There is only one main thing you need to not worry about, but make sure you're paying attention to on which one you define as each matrix. Because if I defined the first one under C instead of A, but I call it up as A, it's going to give me something different. So we need to make sure we're calling them the correct ones when we plug them in. But other than that, that's all there is. I mean, we can still do multiplication with matrices, because I can say second matrix A, second matrix B, and we can multiply them together, and the calculator will do that. Even though we haven't gone over it yet, it will still do the multiplication for us. And that's it.